Hello everyone, and good morning to our students. I'm Mr. Ndenga Elphas, ready to take you through mathematics on your channel number 1, that is KUTV Elimu Live. Welcome to our lesson today, and as always, get ready with your calculator, with your writing materials, so that we look at the topic of our discussion today. Today we are analyzing a Form 3 topic called sequences and series. So welcome. Now in this topic we are going to break down into two main areas. We'll look at what we call arithmetic sequence, and then we'll look at geometric sequence, because those are the two components that we have to understand in this topic, sequences and series. And then from each component we'll be able to take through a series of questions and help you as a student as you prepare for your exams. Now before we analyze what is in this, I want you to look at the objectives that we've set for our today's lesson, and then thereafter we'll go deeper into each one of them. So we are discussing the topic sequences and series, and by the end of this lesson, we expect that you as our learner, you'll be able to identify two main things. One is you should be able to identify the nth term of an arithmetic sequence, and number two, we should be able to identify the nth term of a geometric sequence. And then if time allows us, we shall be able to look at a series part of this topic. Remember, it is one topic, but it is grouped into two parts, that is sequences and series. And so before we look at what each of these that we've listed as objectives has to do with, it is important to understand where we are coming from in this topic. And if you all remember, in your primary mathematics, you looked at something we call number patterns. Number patterns is the basis on which sequences is built from. And so you have to know a certain order in which a certain number pattern has been derived from. And so there has to be a specific formula that is used to get the next number of that particular pattern. And you have different patterns. Let me show you one that we can be able to identify. If we have this, if we have what you call this as my number pattern, that is 3, 5, 7, and 9. Those numbers are appearing in a certain order, in a certain pattern, based with a certain principle. So you can be able to tell that the first case, in the first case, we have the number. In our first case, we have the first term, which is 3, and then we have 5 as the second number, 7 as the third number, and 9 as the third number. You can predict the next number looking at the way in these numbers have been arranged. And so you can see from 3 we have to 5. Then 5 we go to 7. From 7 you go to 9. From your primary mathematics, this was the kind of structure you used to draw to identify the next sequence, the next number in this sequence. So you will draw something close to this. You'll draw something close to this, and then you must have been told, identify the difference between the second and the first. And so this is a difference of 2, meaning we are adding 2 in each case. And so if I add 2 again here, then the next number in this pattern will be 11. If I'm to get the next number again, I will add 2 to now have 13. Again, I can add 2 to have 15, and so on. This is how we get the number in this pattern. And so that is a case we call number patterns, and that is what is used in your primary mathematics. Now, when we come to this case, we are calling them sequences. It does not make any difference. They are the same. But now, we are going to look at a case where we are going to deduce a relation or a formula that will be able to tell us the next number in any series without drawing, because at some point we may find a sequence that has more than 10 terms or more than 10 numbers. Then in that case, drawing becomes a bit tedious. So you have to form a formula or deduce a principle that will help us to get the next number in that sequence. And so let's stick to first understanding what is a sequence. And we are saying that a sequence is simply an arrangement of objects, an arrangement of either objects or a set of numbers in a particular order followed by some rules. So there has to be a rule that is guiding us to be able to set the order of items and objects or sets of numbers in this particular case. And we are saying that each number in a sequence is called a term. So a sequence has what we call terms. So in the description, these objects actually are what now constitute what we call the terms. The numbers are what we are calling the terms. And so in this case, like 3 is a term, 5 is a term, 7 is a term, and 9 is a term. These terms are in an order. And in this case, 3 becomes the first term, 5 becomes the second term, 7 becomes the third term, and 9 becomes the fourth term. And so we can keep on counting up to a certain number of n terms, where n can be defined by any number. Again, in the second case, 10 is a term and is the first term. 14 is the second term. 18 is the third term. And 22 is the fourth term. You can also tell that there is a certain rule that has been followed to identify the next term of this sequence. In the first case, 10 being the first term and 14 being the second term, then you can easily tell there is an addition of 4 to get the second term. If you look at the second term comparing with the third term, then there is an addition of 4 again. Third term and the fourth term, there is an addition of 4 again. And so from this is what we're calling now our rule. The rule here is add 4 to get the next or the consecutive term of the sequence. So our students then, using this as our example case or our case example, what is the next term in our sequence? What is the next term in our sequence when you have 10, 14, 18, and 22? Yes, the next term becomes 26. Why? Because I will also have to add 4 on this term to then get what we have as 26. Good. Again, we can tell the next term, the sixth term, by simply adding 4 to this one, and so I will be able to have the next term as 30. That is how we determine the next term in a pattern. And that is what we have to do in our lesson today. And more specifically, we are going to narrow down to two parts. We have what we call arithmetic sequence and a geometric sequence. So I believe now we are ready now to discuss the objectives of our lesson today, discussing the arithmetic sequence and geometric sequence. So let's then look at what this implies. Now, when we talk of an arithmetic sequence, what we mean is simply any sequence of numbers that has a common difference. The common difference here is simply the difference between consecutive terms in a sequence. The difference between the consecutive, here consecutive means the terms that follow each other. If you are talking about a sequence of 3, talking about this sequence of 3, 5, and 7. If you talk about the sequence 3, 5, and 7, then what we are meaning is that the first term is 3, and the second term is 5. The third term is 7. And so, there is an order that has been followed to determine the next terms. And this order is what you are giving, what you are calling the rule that we observe in determining the consecutive term. If you compare the second term and the first term, there is a difference, because if you take the first term, the second term is 5, you minus the first term 3, then you obtain an answer which is 2. Similarly, if we take the third term 7, you minus the second term 5, you get your solution is again 2. Now this 2 is constant and is a common figure that we are calling the common difference. We are calling the common difference because it is the difference between terms between the consecutive terms of this sequence. When you obtain this case, then we call this an arithmetic sequence. You call it an arithmetic sequence. So an arithmetic sequence is simply that sequence which has what we call the common difference. And the common difference, I'm saying, it's simply the difference between two consecutive terms. If you take the second term minus the first term, you get an equal value to the third term minus the second term, and so it will be the fourth term minus the third term, and so on. This term is what you're calling the common difference. So in short, therefore, an arithmetic sequence is characterized by the presence of a common difference. Good. Then let's see further. We are saying that the first term is 3 and the common difference is 2, and I've shown you how you get the common difference. And you're saying that this difference is what you're calling the common difference 2, that is helpful to in determining the next number of the sequence. And so you can tell now, in this sequence, the next number will be 9. If I add the next, it will be from 9, I will then move to 11, I will move to 13, and so on, up to a certain number of terms that we will be looking at. And so, what I want you to note is this, that in a general form, the arithmetic sequence is given in this case. For example, if the first term is A, the second term will definitely be A plus the common difference. Let's do it practically and show you what we are meaning by this. Now let's take, for example, this term that has 3, 5, and 7 as our terms. The first term is 3. The first term is 3. And so this now represents my A in this case. That in this case, A is 3. So how do I get the next term? The next term, which is 5, we are saying is simply A plus D. And what is A? A is 3. So now it is 3 plus the difference is 2. And then we obtain 5. That's why 5 is the second term. In the third case, in the third term, we'll have now A plus 2D. So we'll say now the third term, which is 7, 7 should be equal to A, which is 3, plus twice the common difference. And what's the common difference? It's 2. And so you obtain a figure 3 plus 4, and you'll find this is exactly 7. And that's why 7 is the third term. And the rule can still apply to as many terms as we can. Now, you can guess, for example, if I want to obtain the next term, which will be the fourth term here, I will simply say it will be now A, which is 3, plus, now it will be 3 times the common difference. So it is 3 times the common difference 2. And so you'll find this is 3 plus 3 times 2 gives us 6. And 3 plus 6, your answer is 9. So I'll comfortably write 9. And so that is how we can be able to deduce the relationship between the terms in an arithmetic sequence and the common difference. Therefore, students, note that if you have the first term of an arithmetic sequence as A, then the second term will be A plus D, where D is the common difference. The third term will be A plus 2D. And so D again is the common difference. And so it should keep on in that order up to a certain number of terms that the examiner will be asking you to determine. And so let's be able to deduce a general principle or a rule that we are going to use in calculating the nth term of an arithmetic sequence. So this is what we do. In this case, then, the nth term of an arithmetic sequence, the nth term of an arithmetic sequence is given by this relation. And as you can see, the relation is given by A, it is A plus n minus 1, we multiply by D. And in this case, A, remember, is our first term. A is our first term. This is our first term. And then n is what you're saying, the number of terms. So if you are asked to determine 10 terms, then n will be 10. If you are asked to determine 20 terms, then n will be 20. So we are saying that the value of n represents the number of terms in the sequence. And then D, we've discussed D and say this is the common difference. That is the common difference. And the common difference, I've already explained to you that is the difference between two consecutive terms of any sequence, and in this case, the arithmetic sequence. And so let's be able to bring this in practice in relation to this case of our sequence 3, 5, 7. And then 9 can also be in the same sequence. So I want us to look at value 7. And then 7, in this case then, if you look at the sequence 3, 5, and 7, and 7. Then we have the first term is 3. So our first term in this case is A, given by 3. Our second term is 5. Our second term is 5. Our second term is 5. And our third term is 7. So let's try to see if this formula will make sense in our calculation and see how it works. I want us to determine the third term, which is 7. We are saying it is the first term plus the number of terms minus 1 times the common difference d. So I will replace it here and say, now my third term implies that n is equals to 3. If you are asked the third term, we are saying n is equals to 3. And so it will be replaced in the formula a, which is 3, plus the value of n, which is 3, we minus 1, and then we multiply by the common difference. The difference between these terms is 2. So let's put 2 at this point. This will give us 3. This will give us 3 plus 3 minus 1 is 2. 2 times 2 is 4. So we add 4. And our solution is 7. And you can be able to see it is actually 7 as our third term. And this formula can be of help to any number of terms that you are asked, as long as there is a rule that is in line to what we are explaining to be the order of an arithmetic sequence, that there has to be a common difference. And if you have the common difference, then you'll be able to apply the formula. Let's further look at what to do with this formula. If we are, for example, as in the same sequence, to determine the 20th term, if you are to determine the 20th term, then in this case, what it implies that n is equals to 20. N will be equal to 20. So students, substitute this in your formula. Your formula is a plus n minus 1 times the common difference d. So I want you to substitute each value, each component in your formula and use your calculator. Maybe in 10 seconds you should be able to do that, and then we can get the solution. A plus n minus 1 times the common difference d. Remember, our a is 3, our d is 2, and now we are determining the 20th term of the sequence. Saying that means that n is equals to 20. Good. This is what you should be able to have. A is 3, so I hope you've written 3, plus n, which is now 20, minus 1, times the common difference, which is 2. Good. that is 20 minus 1 gives us 19. Times 2, that should be 38. And so you have 3 plus 38, which gives us 41. And that is the 20th term of the sequence. And so, as you can be able to see, it is easier to use this rule and this formula because it is much simpler than drawing. Remember what we were drawing in the first instance, where we were looking at a general case, as we used to do in primary school. What you were drawing was simply this kind of structures or diagrams. So you will draw the difference here is 2. And so you'll get the next term, which is 2, add 2. Again, the next one you add 2, you get that will be 9. So you'll find this method will take you a lot of time and too much space to get to the 20th term. You see, at this point, I've only written 5 terms, but we've been asked the 20th term. So it becomes so tedious to work out using that method. And that's why it's important to master the formula. The formula and the principle or the rule that we are going to use is A plus n minus 1 times the common difference D. And that is easier than drawing the structures. Therefore, students, I believe that is clear so far in relation to arithmetic sequence. Let's take more examples before we get to the next sequence. If we look at this case, you're told, given the arithmetic sequence 4, 11, 18, and so it continues, we find the common difference, and then part B, we determine the 8th term of the sequence. Given the arithmetic sequence 4, 11, 18, we find the common difference, and then B, we determine the 8th term of the sequence. Good. I hope you've written the question, and so we can be able to work it out together. So our solution will be 4 is our first term, 11 is our second term, and 18 is our third term. And these terms will have to continue in this sequence. The first term, the difference between the second term and the first term, that means 11 minus 4 should give us 7. If you do it again, the third term minus the second term, you will still find to be the same value. 18 minus 11 should give you 7. So this is what we are calling the common difference. That is what you are calling the common difference. So in this case, therefore, our solution for our common difference D is equals to 7. I hope, students, you can be able to see that, and you've gotten the same answer, 7. That is the common difference. Part 2, we need to determine the 8th term of the sequence. That is where I'm saying, to get a number of terms in the sequence, you obtain you find the value, using what we call the principle or the formula rule that we are using applying in arithmetic sequence, which is A plus n minus 1 times the common difference. So let's work out using the formula and see. To get the 8th term of the sequence, then we need to remember that the 8th term of any arithmetic sequence is given by A plus n minus 1 times the common difference D. That is how we get the nth term. In this case, our A is the first term, which is 4. And our common difference is 7. So we will say now, replace in and have 4. Remember, this is the 8th term. The 8th term is equals to 4 plus n, which is now 8, minus 1 times the common difference, 7. Substitute this in your calculators. You should be able to have 4 plus. Now 8 minus 1 is 7. 7 times 7 is 49. And so when you add 49 plus 4, you get is 53. And so the 8th term of this sequence is 53. It means the 8th term is 53. Someone else could have done it using the manual way. By adding 7 all through, you will still get the 8th term. But then you will have taken much time than when you substitute it in the formula and work it directly, as we've done in this example. Again, if someone asks you in the same sequence, determine the 20th term, it means the same thing. Replace in the values for A, replace in the value for D, and then the value for N now becomes 20. If you are asked the 30th term, the value of N becomes 30. So we keep on changing the number of the value of N depending with what you've been asked as the number of terms to be determined. So let's further look at another case. You're told, number 2, find the 45th term of the arithmetic sequence. You find the 45th term of the arithmetic sequence -9, -2, 5, 12, and so on. So in this case, again, what we'll do is for us to be able to identify if indeed there is a common difference. So we have -9, the second term is -2, the third term is 5, and the fourth term is 12. You can tell the common difference again by taking the difference between the second term and the first term, or the third term from the second term, and so on. So let's try and get our D. In this case will be now -2 minus 9. Minus, that gives us a positive value. So we have a positive in this case, and so -2 plus 9 is 7. So the common difference is 7. Students, what is now the value of N? What is the value of N? Remember, we are determining the 45th term, and we have said our D is 7. So what is N? Yes, our N is 45. And what about the value for A? A is -2. So let's replace them in our formula and substitute this. We'll then say our 45th term, that is the 45th term, will be given by the formula A plus N minus 1 times the common difference D. So you replace in A, which is now -9. So I'll have -9 plus N. Value of N, we are saying, is given by the number of terms you're looking for. So we write 45 minus 1 times the common difference, which is 7. So you have -9 plus 45 minus 1 times 7. Those who have calculators, help us work out this. That is 45 minus 1 should give you 44. You multiply by 7, that should give you 308. I hope you have that in your calculators. -9 plus 308. And so -9 plus 308 gives you 299. Thank you. That is our 45th term, 299. Because we are going to find there are some cases where the arithmetic sequence rule cannot apply. So if that happens, then the only alternative method will be the application of the geometric sequence. So let's look at what is in this case. Now, if we consider the following sequence. Let's consider the following sequence. And the sequence that we are considering has a term, the 3, then we have 9, and then we have 27. Then the continuous. So if you look at this sequence and you compare to the previous sequences, I want to write it here, but just to compare, look at this one, 3, 5, and 7. This was the first case we were looking at. And we said this is an arithmetic sequence. But now, this one has 3 as the first term. The second term is 9. The difference between these two is 6. If you look at the second and the third, the difference is not 6 again. It is now 18. And so you find that you cannot tell that this sequence has a common difference. But rather, there has to be a different rule that we adopt to be able to conclude whether it is the common difference or something else that I want us to discuss. So what is this that is happening when you find this kind of a sequence? So this is what we do. We compare the first and the second term, but then we do comparison based with the ratios. That is, we divide the two terms. So if you take the second term over the first term, then you'll have 9 over 3. And that will give you 3. Again, if I take the third term, and the third term in this case is equals to, the third term in this case is equals to 27, and the second term is 9. Again, you'll obtain 3. And so these are equal. And so when we divide this kind of case, we obtain what we call the common ratio. We obtain what we call a common ratio. And the common ratio, we use letter R. Remember the common difference, we were using D. And so the common ratio becomes R. Therefore, students, a geometric sequence has common ratio. An arithmetic sequence, it has a common difference. That is the difference between the two. That in the first one, there is a common difference between the terms. And in the second one, which is geometric sequence, it has a common ratio. And the common ratio here, we are taking the second term over the first term, or the third term over the second term, and it could be the reverse, the first over the second, and so on. So that is how we identify the difference between the common difference in the arithmetic sequence and the common ratio in the geometric sequence. Let's look at a general rule, deduce a general rule that we apply in determining the nth term of this sequence. Now, generally, for a geometric sequence, the nth term is given by a r power n minus 1, a times r power n minus 1. You should be able to tell what each of the variables in this formula mean, where a remains to be our first term. R is what you're calling the common ratio. And then we have n, which is now the number of terms of the sequence. That is the formula that you have to understand and to be able to remember every time you are given a question in geometric sequence. That the nth term is given by AR power n minus 1. I want us to use the previous sequence, which was 3, 9, and 27 to explain this formula and see how it works. Now, you'll be able to see that 3 is the first term, 9 is the second term, and 27 is the third term. So, if we are told to determine the third term, then we know our third term is 27. Our third term is given as 27. But when we talk of third term, n is equals to 3. Third, n is 3. So the first term is again 3. We replace in the formula and say the third term will be equal to a, which is 3, times, now what was our common ratio? When we took 9 divided by 3, we got 3. 27 divided by 9, we got 3. So our common ratio was again 3. So now we have 3. Now we raise it to the power n, which is 3 minus 1. Good. Let's work it out and see. We have 3 times, now we have 3. This is 3 times 3 minus 1 is 2. And 3 power 2, that is 9. So 3 times 9 gives us 27. And indeed, the value was 27. So it is simple. Just get to understand the formula. Once you understand the formula, the calculations will always be simple, as I've shown with the examples. Students, I hope we are following, and we are now good to go to the examples, further examples, and see how we work out a geometric sequence. Good. We move to the example, and let's look at an analysis of questions. We can look at the analysis of different questions. So we can have questions. And in our first case, you are told that you determine, number 1, you determine the 10th term of a geometric sequence, and the geometric sequence that we are having is 2, we have 4, we have 8, then we have 16. That is the geometric sequence. So what we do is we identify, again, in our sequence 2, 4, 8, and 16, we identify the first term. And then identify the value for n. And then finally, we identify the common ratio. And so how do we get the common ratio? You take the second term divided by the first term, which will be the same figure if you take the third term divided by the second term. And so it will be the same value when you take the fourth term divided by the third term. So let's see it practically. If you take the second term, our R will be equal to the second term over the first term. This is the second term over the first term. Now remember, student, it is not 2 over 1. It is the second term over the first term. So this should give us 4 over 2. And so your solution in this case is 2. Again, if you took 8 divided by 4, you will still get 2. And so will it be if you take 16 divided by 8, it will still remain to be 2. So we now substitute in our value for a again. Our a is equals to 2, and that is the first term. The common ratio is 2. And now we are looking for the 10th term. In this case, the 10th term implies that n is equals to 10. So I will have a r power n minus 1. This will give us a, which is 2, times r, which is 2, power, now n is 10. 10 minus 1. Students, substitute this in your calculators. You have, that is 2 times, that is 2 times, now 2 power, that's 9, that is 2 power 9. And 2 power 9, what is 2 power 9 from your calculators, students? 2 power 9, you multiply by 2 power 9, you multiply by the value for 2. Yes, any student who has gotten the value? 3 times 2, 3, 4, 5, 6, 7, 8. That should be 512 times 2, which is 1024. Good. This is equals to 1024. So your solution for the 10th term is 1024. Simply follow the steps and remember the formula. You'll be able to work out the value for the nth term. That is our first question. We can look at a second case. And in this case, we are told to determine, that is number 2, we determine the seventh term of the sequence, below, and we have the first value for the first term of our sequence giving us 15, and then we have 45. Unfortunately, they are only given 2 values, so we have to use this as our sequence. Had we been given 3, again we shall still follow the same principle, but we have 15 and 45. Then the assumption that is made, because we are looking at the geometric sequence, it is definitely that we are in a geometric sequence, and so we will work out using the principle for geometric sequence. But had it been a general case, then you shall have to be given 3 values so that you can tell whether it's a geometric sequence or an arithmetic sequence. And so I believe this is given based with the understanding that the subtopic under discussion is geometric sequence, and so it is easier to move from there. So we shall then move as follows. We get our R. Our R in this case will be the second, which is 45, divided by 15, and that should give us 3. That will give us 3. Our A, which is the first term, in this case is 15. Our A is 15, and our N, because we are looking for the 7th term, our 7th term, then our N is equals to 7. So once you have those 3 items, then replacing in the formula is not a big deal. You simply go to your formula. We shall go to our formula and say that the 10th term is equals to AR power n minus 1. And so we'll say our first term, which is 15, we multiply by the common ratio, and our common ratio we found is 3, then power 7 minus 1. This will give us 15 times 3 power 6. So students, again substitute this in your calculators. You have 3 power 6, that is 3, that is 729. 729 times 15. 729 times 15. Yes, what is your answer? That is 10,935. Good. That is 10,935 as our 10th term of the sequence. That is what we talk of geometric sequence. Therefore, students, I believe from the analysis we've made, you can now be able to work out any question relating to arithmetic sequence and geometric sequence. But very important for you to understand them, you should know the difference that exists between the two. When given an arithmetic sequence, then we are talking about that arrangement of elements or of terms in order that has what we call the common difference. The difference between the consecutive terms is what we're calling the common difference. And then the geometric sequence then has what we call the common ratio. The ratio between two consecutive terms of the geometric sequence is called a common ratio. Then get to know how do you identify the nth term of terms in an arithmetic sequence. It's simply by the formula a plus into bracket n minus 1 times the common difference d. Then the nth term in a geometric sequence is given by the formula a times r power n minus 1. Those are very simple formulas to remember, and then they will help you to work out your calculations. Okay, let's look at questions that you've been able to post or ask. Let's see those who have questions so that we can be able to handle them before we conclude our lesson. Now we have the first case here, and this is we're told to find the sum of the first 30 terms of the series. We find the sum of the first 30 terms of the series. Now, when we talk about a series is simply the sum of terms of a sequence. So when we're told in this case, we find the sum of the first 30 terms of the series that is 16 plus 19 plus 22. It all goes to unknown value. That is one of our students who was asked that question. We find the sum of the first 30 terms of the series. Again, students know we have a series and a sequence. The difference is very small. When talking about a series, we are talking about the sum of terms of a sequence. And that's why in most cases, for a sequence, we separate the terms using commas. But for a series, we separate the terms. We don't separate the terms, but rather we write them using addition sign. So you'll find for a series, there is plus. For a sequence, there are commas, because a series is the sum of terms in a sequence. And therefore, it then tells you that we have two series. We have an arithmetic series and a geometric series, because we have talked about arithmetic sequence and a geometric sequence. So when you add the sum of terms in a arithmetic sequence, we obtain an arithmetic series. The sum of terms in a geometric sequence gives us a geometric series. And we also call them propagations. And that's why you have what we call the AP and GP, which are used to denote arithmetic sequence and geometric sequence respectively. So let's help our student with this question. First, we have to identify whether it's an arithmetic sequence, a series, or a geometric series. And so the difference between these two is 3. Again, The difference between these two is 3. And so it tells you that this is what we call an arithmetic series. This is an arithmetic series. And so how do we get the sum of terms? So sum of terms in an arithmetic series is given by the formula n over 2 into twice a, you less n minus 1, you multiply by the common difference d. For those who are wondering where is this coming from, we had not looked at this part for the series, but we understand because it's a revision case, you know this formula, and that's why our student who is watching us from somewhere has posted this question to help him. So this is the formula. N remains the number of terms, and so we are told to determine the sum of the first 30 terms. So what we do, it means that our n is equals to 30. Our n is equals to 30. Our a is equals to 16. And so we'll now replace in the formula and have 30 over 2 into twice a. 2 times 16, that should give us 32, minus, that is n, which is now 30 minus 1, 29, times the common difference 3. So students, replace this in your calculators again, then let's have our solution. That is 30 divided by 2, we have 15 into 32, minus, if you take 29 times 7, that should give you 87. Yes, 87. So we have, that will give us someone kindly check this. This is plus, sorry, this, the minus is in the bracket, so this is plus. If you add, this is 87 plus 32, it should give you 119 times 15, 1,785. Good. That is the value for the 30th, the sum of 30 terms in this sequence. So you simply get the formula, that is n over 2 into twice a plus n minus 1 times the common difference, which is d. So that it will become our solution. We also have someone, that is Daniel from Ndenga Secondary. Daniel has a concern. He needs a 10-mark question, and so we'll be able to give one. Again, we have our viewer, that is Mwendwa. Mwendwa is asking that we find the number of terms in a sequence of numbers that is between 1 and 151 that are divisible by 3. I'll also work out that. Then John has a 15th and the 10th term of the AP, that is 18 and negative 2. Then there is another one. This is from matrices. Someone has sent a question from matrices. Okay, we are not in matrices again, but then we shall be able to help him out. And then we have Eunice, and if I ask about the arithmetic question, will it apply to formula? About arithmetic question, will I apply the formula of arithmetic progression? Yes, if you are looking at an arithmetic series, then you apply the formula for arithmetic progression. And so to summarize that, let's be able to look at this. When you're talking about the geometric sequence, we obtain what we call a geometric series. We shall obtain what we call a geometric series. And a geometric series, it's simply the sum. This one is simply the sum of terms in a geometric sequence. When we add the terms in a geometric sequence, we obtain what we call a geometric series. In this case, then, we have to know that in a geometric sequence, we talked about the common ratio R. So get to know what is R, get to know what is the first term, and get to know what is N. But in calculating the sum of terms in a geometric sequence, there has to be one condition that must be fulfilled. And that condition bases on the value of R. So you must first get the value for the common ratio. Then you compare it with 1. If you find that the common ratio is less than 1, then there is a formula that you shall use to calculate the sum of terms. If the common ratio is more than 1, then we calculate using a different formula. So this is the way we calculate. If R is greater than 1, then sum of n terms is equals to, we take A into, that is now 1 R power n minus 1, then over R minus 1. This formula applies if R is greater than 1. But if you calculate the value of R and realize that R is less than 1, if R is less than 1, then the sum of n terms is given by the formula A into 1 minus R power n, then we divide by 1 minus R. So these are the two formulas that we apply when we are calculating the sum of terms in a geometric sequence. You first identify whether R is greater than 1 or less than 1. And so if we look at the question that has been posted now, let's summarize with what Eunice has asked. What Eunice has asked is that we find the sum of terms. We find the sum of terms of the series, the sum of terms of the series, that is 2 plus 6 plus 10 plus 14 plus 18 all the way, that will give, that will give a sum of 800. That is there's a correction on that question. I think this is find the number of terms, because we have been given the sum, which is 800. Then it means then we need to determine the number of terms. Find the number of terms. Find the number of terms. Number of terms of the series 2, 6, 10, 14, 18, that will give a sum of 800. If we look at this again, our first term here, A is equals to 2. Our A is equals to 2. Look at the 2 and see if it is a common difference or there's a common ratio or a common difference. As you can see, from the first one is 2, the next is 6, the difference is 4. 10 and 6, the difference is 4 again. 14 and 10, the difference is 4 again. So this means that it has a common difference D, which is 4. And therefore that tells us that this is an arithmetic sequence, arithmetic series originating from arithmetic sequence. So the sum of n terms, therefore, is n over 2 into 2a plus n minus 1 times the common difference D. So we'll replace in the figures that we have our n. We don't know what is n, but we have the sum, which is 800. So I will substitute in 800 is equals to n, which is what we are looking for, over 2 into twice a. 2 times 2 gives us 4, plus, that is n minus 1 times the common difference, which is 4. If you work out this one, then we will have if I work out this one, I'll have 4n. We'll have 4n minus this will give us 4n minus 4 plus 4 is equals to plus 4, that is we times by n over 2. N over 2 is equals to 800. Then that gives us 4 minus 4, that should be 0. And so we have 4n that is times n over 2 gives us 4n squared is equals to, I multiply 800 by 2, that is 1600. Then we divide this one by 4. This is 4n minus 4, that is 0. Divide this one by 4 to give us, divided by 4 cancels. So n squared is equals to 400. And so how do you get n? N is the square root of 400, which is equals to plus or minus 20. And so since we have a positive value, then our value's number is 20 times. That is 20 times. So I think, Eunice, you've been able to see your solution and the question regarding to the number of terms. Okay, we can have so many questions to be discussed. There is one who has asked about the 10-mark question. The 10-mark question is actually when you're looking at the value for the arithmetic sequence and geometric sequence combined, then we'll be able to obtain a 10-mark question that you can be able to look at. So we'll be able to share more in our next lesson. Thank you for watching KUTV Elimu Live, and always keep practicing. Math is about practicing and doing more. Do not stop working after this lesson. Do as many questions as you can, so that when we meet next time, you'll be at an advantaged position to work out any question from sequences and series. Thank you so much, and enjoy the rest of your viewing on KUTV.